So we've got our transport nodes prepared. We've got everything set up. We've got our managers deployed. We're ready to go with NSX. There's one more thing we want to talk about before we really get into a bunch of what we're actually doing with NSX, and that is DPU based acceleration. Now, what is DPU based acceleration? Well, these are things you might have heard of called SmartNICs. Data processing units is really what DPU stands for, and so we're going to talk about what we support, why we support it, what we're going to do with it, how we're going to take advantage of this kind of stuff. Now, there's not going to be a lab with it because there's hardware required. Naturally, I have to have a SmartNIC in order to configure a SmartNIC. But there's some really cool stuff to think about here as we're moving forward, thinking about DPUs in our future deployments. Now, we talk about this because we have challenges that we face in our deployments today, and really it comes down to resourcing challenges. We can carve that up, that resourcing challenge, into all kinds of different things, right? Isolation, resources, competing with my applications, all kinds of stuff. But we do face challenges with our traditional network infrastructures today, particularly at the hypervisor level. And we're finally able to start thinking about addressing these things that let's be honest, virtualization sort of started to bring to the table a great number of years ago. And so data processing units, or DPUs, are also known as SmartNICs, and they're going to help us solve some of these challenges by providing dedicated compute resources on which to run things like our NSX stuff, right? Being able to offload NSX onto the processor on the data processor on the SmartNIC frees up those resources from the hypervisor. It also allows for better isolation between virtual machines, because now the network processing, for example, is not being done in the hypervisor. It is being done on the network adapter itself, right? It gives me better opportunities for observability, because now I can look at data streams right off of the I/O ports without having to consume resources, without having to use that physical hypervisor, that physical server to drive the collection of that data. So there are a huge number of benefits moving forward to using SmartNICs. Now, why are we going to use these? Well, visualization, right? Observability, security offload, reducing latency while increasing bandwidth. These are all different reasons that I'm going to use data processing units in my infrastructure. Now, currently we support two different brands of SmartNICs, right? We support NVIDIA SmartNICs and AMD or Pensando SmartNICs, and that's reliant ultimately on what vSphere is also going to support. So that's our support ecosystem right now. Now, those happen to be two of the major SmartNIC vendors out today, so it's kind of convenient. We would want to support the big ones. So these are the two we support today. Now, with a SmartNIC, as we look at this, a SmartNIC's going to provide compute resources on the card itself, outside of the central processor of the server, to run processes. So, SmartNICs are really used for I/O, right? These are in many ways I/O computers. We could think about them that way, and these are going to run processes related to NSX for our network I/O and our security I/O, and some stuff for ESXi, right, related to storage and virtual SAN and things like that, so that we can have that I/O acceleration as well, that storage acceleration and separation, as well as the network I/O and security acceleration. So we can offload a whole lot to these smart NICs. So what do one of these smart NICs look like? And it doesn't matter whether we're looking at an NVIDIA smart NIC or a Pensando smart NIC. They're going to have the same approximate architecture here, like what we're showing on the screen, where we've got, our network ports, and those network ports are attached to a hardware accelerator and a programmable accelerator, which is driven by a processor on the smart NIC itself. And that processor has flash memory associated with it. It's got storage associated with it. This is very much a system on a chip kind of configuration here that we're looking at, giving me literally a network processing computer, like I said, an I/O processing computer on this smart NIC card with direct I/O. Now, this is not going to replace the server itself, right? This is just a little, small computer dedicated for I/O processing. And through that, we can then offer para-virtualized, or virtualized rather, devices, network and NVMe devices that can then be presented to virtual machines and used by virtual machines, essentially bypassing the I/O stack in the server and working directly with the I/O stack on the smart NIC itself. So with these virtualized network functions that we have available now, we can take advantage of them and use them a couple of different ways depending on your virtual machine configuration. There's a pass-through mode that we can literally, the VMXNet NIC can actually be a pass-through device attaching directly to the smart NIC. Or if maybe I have a virtual machine that's got a little bit older virtual machine hardware version that can't support that new VMXNet device, we can use a standard VMXNet 3 NIC and use an emulated pass-through, accelerating everything on the virtual switch. And so, that's going to allow for this acceleration through the fast path, through basically a flow table, very similar in many ways to a firewall that's going to maintain a connection or a flow table. We can maintain this fast path table, and if we miss on that fast path table, then we work through what we call the slow path, which is a slower processing path. It's still accelerated by the smart NIC, but it's slower than our quick. We match a rule and forward on. So, the traffic can go through. And if we allow the flow to go through, then the hardware table is updated. And then the next frame that comes through is going to hit the hardware table and be processed through the fast path. So we're adding a layer of complexity in this additional hardware and the processing and compute happening on that particular hardware. But we're doing that in a pass-through mode, so we can not quite completely bypass the vSphere configuration, but fairly close. We can do in NSX 4.0.1 DPU acceleration for layer 2 and 3 networking, for VLAN, for trace flow and IPFix and observability. We can offload intrusion detection and prevention, at least prevention as a tech preview. We can offload distributed firewall, meaning that we can accelerate these capabilities and add a whole new performance dimension to your NSX data center. Now, if we look at the traffic flow, we send a packet from the virtual machine. The virtual machine is going to send the packet through the virtual NIC, through its VMXNet 3 NIC. That's going to get passed on to the DPU to its connection tracker. Right, that was the hardware table that we mentioned a minute ago. If we have a pass, right, we have a match on that connection tracker table, we move through the fast path and shoot the packet on, and off we go. If we have a miss, we simply go through and process that based on the rules in the smart NIC that are programmed into the smart NIC, and we'll act on the packet from there. We'll either forward it on or we'll drop it, whichever way we need to go, and update the hardware table accordingly. So we can configure smart NICs a couple of different ways. Now, I am limited, perhaps, is a better way of saying it. I am limited to a single smart NIC per hypervisor per ESXi host right now. Now, it's not a big deal because all of our SmartNICs are dual port network adapters, meaning that, I have my uplink redundancy if I'm going to use those. And I can attach the SmartNIC, the data processing unit, ports as uplinks to my virtual switch, to my distributed switch, and use those. Or here we have two virtual switches with one uplink each. I think it would be one virtual switch with two uplinks would probably be the way we go. But since I can only have one SmartNIC, and today there are only SmartNICs with two ports, that means I only get two SmartNIC uplinks per hypervisor. So I can put everything on a SmartNIC back virtual switch, or if I have existing network adapters that I'd like to use, I can use multiple virtual switches and put my SmartNIC uplinks on one virtual switch. So I have one DPU accelerated virtual switch and one or more virtual switch that's not DPU accelerated, that's doing all the same networking that we've been doing for years and years and years now. Again, SmartNICs, I can have one per hypervisor, and that SmartNIC, those uplinks, have to be owned by a virtual switch. I cannot mix and match, meaning that if I have a SmartNIC uplink on a virtual switch and I want to add a second uplink to that virtual switch, that second uplink has to be a SmartNIC uplink, right? I cannot mix smart and standard NICs on the same virtual switch, right? I can mix and match them in the hypervisor, just like we're showing here, where I have a SmartNIC on one virtual switch and standard NICs on the other virtual switch. Now, with NSX, when I'm configuring my distributed switch, first off, I have to configure my distributed switch in vCenter to support network offloads. And so here we see the Pensando or the NVIDIA Bluefield. Those are the two that we support. Now, so I'm going to configure that when I configure the VDS in vCenter. I have to do that first. When I add my hosts, adding compatible hosts means that I'm adding hosts that have a SmartNIC installed. And the uplinks have to be SmartNIC uplinks, right? The VMNIC devices have to be ports on that SmartNIC. Now I can validate which ones these are in vCenter by looking at the ESXi host and looking at the network adapters and seeing that they are SmartNIC enabled, or DPU backed is the actual term here in the UI. Now, when I prepare NSX, I'm probably going to go through the quick start and prepare my clusters here and, go through this process. And as we look through this process and as we set up our transport nodes, notice that the uplinks here, right? Look at this slide, the bottom of the screenshot, we've got it highlighted in blue. The uplink enumerations, right? Uplink 1, uplink 2, those specify that they are DPU accelerated. That's being read from vCenter and showing us that these uplinks have DPU backed VMNIC devices. So this is how I'm going to consume these in NSX, right? I'm going to specify my host switch is DPU. My host switch uplinks are DPU accelerated. And we can also see, just like we could see in vCenter, maybe you're just an NSX admin, you don't have access to vCenter. You can look at your transport nodes in NSX and drill in and look at the physical network adapters, right? NSX is just reading this information from vCenter, and we can see here that we have some network adapters, some VMNIC devices that are SmartNIC backed. They're DPU backed. So we know that we can use these if these are associated with the uplink on my distributed switch. So that's a high level SmartNIC discussion, right? High level data processing unit capabilities with NSX. We talked about the architecture. We talked about what hardware is supported. We talked about the features and kind of how we're going to use them, right? So what have we done in this whole series of videos? we got to wrap up the whole thing here, don't we? We talked about deploying NSX managers on ESXi hosts, only on ESXi hosts. We talked about how they're configured into a cluster, and we've got a policy and a manager UI that we can work with. We're just going to work with policy. We talked about our distributed switches and how we're going to use those on our ESXi host as the host switch. We talked about how the transport zone kind of defines the membership, who's going to get what configuration. We talked about uplink profiles and how we're going to leverage those to change our NIC teaming policies. And we talked about the VIBs that are installed on the ESXi hosts. And we wrapped up finally with data processing units. We've gone through a lot of stuff so far, but we're just getting started. If you come back for the next series of videos, we're going to start talking about cool things like logical switching. That's where we're going from here. But we're going to say goodbye for the immediate moment. All right, we've got to give you a break. So come back when you're ready for the next series of videos on logical switching. We'll see you there.